Graphing the polynomials. This is what we're going to do, okay? First, let's write it the way we like to see it. That's 2x to the fourth minus, you only just switch them. That's not a big deal. Okay, let's find our x-intercepts. To find our x-intercepts, we have to plug 0 into the y. So when I do that, I get 0 equals 2x to the fourth power minus 18x. In order to solve this squared, I have to factor. So I'm going to factor out a greatest common factor first. So I get 2x squared, and then I get x squared minus 9. Ooh, check that out. I can factor it even more. So I have 2x squared times x minus 3x plus 3. And after that, you should be like, I know all the x-intercepts now. 0 and plus or minus 3. Because each of these numbers would make one of these factors equal to 0. So we have 3 x-intercepts. Let's go graph those diggity doggies. All right, so at 0, we put a dot right there. At 3, we put a dot. And at negative 3, we put a dot. Those are our x-intercepts. Let's find our y-intercepts. We have y-intercepts. To find our y-intercepts, we plug 0 into the x to find our y-intercept. Oh, snap. It's like the other one, but the other variable. To do this one, we just have to plug the 0 into all those x's. So we get 2. Yeah, you guys can probably see it already. I don't know why I'm writing this. 18, and then we have 0 raised to the second power equals y. What do we get? 0. So our y-intercept is the same as our x-intercept right here. So it's not helping us out with graphing it at all. What was the other thing that we had to do? We had to find out where y equals 3, right? Or y equals 3. So we got to find the x when y equals 3. So we do that. We plug 3 into the y. So we get 3 equals, oh, this does not look like fun. Oh, look at that. Oh, snap. That does not look like fun. You know what you have to do? You have to move the 3 to the other side so that this side equals 0. And then we have to factor this dude. Is that dude factorable? No. All right. I see an x squared and an x to the fourth. Let's see really fast if we can do this big x thing with it. We have negative 6 and negative 18 on the bottom. What times what gives me negative 6 but then adds to give me negative 18? Anything? Anything? We have 1 times 6, which will not give me 18. We have 2 times 3, which will not give me 18. It looks like it's not factorable, so poop on that idea. What's the other thing that we could do? Nope, not complete the square. Does this look familiar? Possible rational zeros. Oh man, this stinks. All right, so possible rational zeros, we take all the factors of the last one, which is going to be plus or minus 1 and plus or minus 3, and then we divide that by all the factors of the first one, which is plus or minus 1 and plus or minus 2. Okay, snap. So that means we have a lot of different possible rational zeros. Now it's synthetic division time. So we got 2, 0, negative 18, 0, and negative 3. Do you guys know where all those numbers came from? Okay, I'm doing synthetic division. We have a 2 because the leading coefficient here is 2. We have a 0 because we have a missing term, the x to the third. We have negative 18 because we have an x squared, with negative 18. Then we have a 0 because there's no x, and then we have a negative 3. All right, which number do you think is going to give me a 0 right here? Let's try 1, right? 1 divided by 1? Yeah. Let's try 1. Okay, so I try 1, I get 2, get 2, and then I get 2, and then add those, I get negative 16, and then I put a negative 16 right here. I get negative 16 again. If I go negative 16 times 1, am I going to get a 0 right here? No. All right, this one stinks. All right, what about negative 1? Huh? So we get negative 2, and then we get negative 2, and then we get a positive 2, and then we get a negative 16. Hey, same scenario, huh? We get positive 16. That's not going to give me a 0 at the end, so negative 1 doesn't work. Oh, this stinks. All right, not negative 1. Let's try another one. 3? Yeah. Let's try 3. So we bring down a 2, then we get a 6. We get a 6. We go 6 times 3 is 18. We get 18. We get 0. We get 0. 0, and then 0. Boo. We were getting really close on that one, huh? Oh, man. What about negative 3? Do you guys think negative 3 will work? So you bring down to 2, we get negative 6. Negative 6 times negative 3 would be positive 18. Hey, we get 0 again. Wait, did we get 0 last time? Yeah. Did I do all my math right? Whatever. Okay, then we get 0 times -3, which is 0. I look at your faces. You all look really tired right now. We don't get 0 yet again. Oh, man. That looks like we're going to have to bust out a fraction. All right, so what do you guys want to do? You guys want to do 1/2 first, or do you guys want to do 3/2? 1/2 it is. Oh, man, I hope this works. So I bring down to 2. 1/2 times 2 is 1, and then I get a 1. 1 times 1/2 is 1/2. Oh, this is disgusting. That's not going to get me. It's not going to work, right? No, it's not. It's not going to work. Okay, what about a -1/2? Do you think that's going to work? No. I don't really want to try -1/2 either. I don't think that's going to work either. My money right now is on 3/2. The last one that we tried, did you say I would try that the first time?
Yeah, because
oh, you be quiet. 2 times 3 is 3. Then I get a 3. 3 times 3/2 is going to be 9/2. And then I have to add 9/2 to 18. -18 with the 2 denominator, it will be -36/2. And I add those, I get -27/2. And that times that is going to not be, okay, is that going to give me a 3? I don't think so. Well, let's find out. What's this times this? What's 27 times 3? That's 81, right? Yes, it's 8. So we get -81/4. That's nasty. Okay, I'm running out of space. -81/4. Do you guys know what 81 times 2 is? Or times 3?
81 times what?
I don't know, but whatever it is, if I divide it by 4, I'm probably not going to get 3. Okay, so that one doesn't work. Should we try negative?
Is this going to be
No, this one won't be. Yeah. I told you guys, the review is harder than the actual test. Okay. All right, so now we would try this one, and then we're hoping that, and we're praying that we get a 0 right here. And if we don't, that means this is, like, not divisible. We can't solve this. Okay? I'm just going to pretend we can't solve it so we can move on. Okay? Because I'm tired of doing fractions right now. All right, so now we got to graph this dude. We got our x-intercepts, we got our y-intercepts, end behavior, right? Do you guys remember end behavior?
Yeah.
What is our end behavior for this dude? The end B. So as x approaches the left side of the graph and as x approaches the right side of the graph, what is y doing for each of those? Okay, and now if you want to answer this question, you have to know the degree of the polynomial function and the leading coefficient. Our degree is what? Odd or even? It is even. That means we're going to go up, up, or we're going to go down, down. Okay, so it's either going to be positive, positive, or negative infinity, negative infinity. So what about our leading coefficient? Is our leading coefficient positive or is it negative? It is positive. That means we're going to go up, up. It's not going to be this guy. It's going to be positive infinity, positive infinity. And I'm going to put my end behavior corners up here so I can graph this dude. I'm going to start up here. I'm going to go through, bounce, and then through. Oh, you know what? I jumped the gun. I didn't talk about going through and bouncing. Okay, so for each of these points, we have to know if we're going through or bouncing. So we have to look at our zeros right here and see the factors that they are coming from, which is this factor, and this factor, and look at their multiplicities. Their multiplicities lie underneath the exponents. Now, for these two factors, we have multiplicities of 1. Now, if we have a multiplicity of 1, that means you go through. So, for those two zeros, I'm going to put a t right there and a t right there because we're going to go through. Okay, this 0 right here is coming from this x that is squared. That's an even multiplicity. If you have an even multiplicity, you guys remember what you're supposed to do? Bounce. Bounce with me, bounce. Okay, there it is, a b. So now I'm going to go, we bounce, we, yay.